All right, number 3, same thing. We have 3 parts. We want to find the degree and the y-intercept. All right, so the degree, I'm just going to read it from the computer. We have this x minus 3 to the 7th, so that counts as 7 x's, plus this one is 1 more, so we got 7 plus 1, which will give us 8. So we have a degree of 8 in this first one. And then our y-intercept, so this is going to be a much, much bigger number. Y-intercept, you will plug a 0 for x. So I will have 0 plus 4, and then I would have 0 minus 3, and that is to the 7th. So this would just give me 4, and this would be a negative 3 to the 7th, so that's going to be a big number. I will definitely use a calculator to compute that. So if I do negative 3 raised to the 7th, I get 2187, and then I have to multiply that times 4. And that gives me negative 8748. So this is negative 8748. And so as an ordered pair, x is 0 and y is negative 8748. Alright, so now we want to know x-intercepts where it crosses, and remember it crosses at every odd degree. So it will cross at both of these numbers. And so the first one we would get negative 4, 0. So remember you would set this equal to 0 and subtract 4. And then over here you would set this equal to 0 and add 3. So that would give us a positive 3, 0. And then we want to know zeros where it flattens out. So it will flatten out at anything greater than 1. So just this one. So just 1, 0, and that was 3, 0 as an ordered pair. All right, so number 4, we have 4 parts. We want to factor the polynomial completely, and then we'll go from there and see what else they want us to do. So this is why they wanted us to remember the Cartesian rule of sines and some of those other things that we've been over. But we're going to use the calculator to help us out. So we have this polynomial, f of x equals, and this is x to the 4th plus 6x to the 3rd plus 6x squared minus 12x minus 16. Okay, so because of 4, that means we would have at most 4 zeros. We could factor this and get the possible zeros, but we're going to use the calculator and just see how close we can get to a few of them and then get it to a point to where we can factor it. So I'm going to type this into the calculator. X raised to the 4th, arrow over, plus 6x raised to the 3rd, then arrow over, plus 6x squared minus 12x minus 16. All right, we're going to graph this, and I am just looking at these little tick marks and trying to count and see if I can tell where it is crossing. So it looks like, because this goes to 10, negative 1, one of them is crossing at negative 2, negative 3, and then one at negative 4. It's negative 5, negative 6, negative 7, 8, 9, 10. So one of them is a half or some other number, but it looks like -1, looks like -2, and -4. But let's verify. So let's do trace, and I'm going to type -2, and I'm going to hit enter. And you see the y value is 0, so that confirms. So -2 is one of them. And then I'm also going to type -4 and then see what we get. So also look, -4 is one of them. So what I'm going to do is I'm going to do synthetic division with x equals -2 and -4. So I'm going to do my little half box, -2. And then I'm going to start with the coefficients only. So 1, 6, another 6, -12, and then -16. So you got to remember, now I just kind of jumped into it, but remember, you got to have all your terms, meaning whatever your biggest degree is, you got to count backwards to 0. 4, 3, 2, 1, 0. So when you know that you have everything, then you can list your coefficients. And then we do synthetic division. I'm going to bring this first number straight down, multiply by -2. -2 times 1 is -2, combine, and we get 4. -2 times 4 gives me a -8, combine, and we get -2. -2 times -2, +4, combine, and we get -8. And then -2 times -8, +16, combine, and you get 0. So that's how you know it's a 0, when the last term is a 0. So look, this was an x to the 4th, so now this is an x cubed, and we would count down. But I do know another 0, so I know that -4. So I'm going to pick up with -4 and go from there. Now the reason why I'm pointing out this is x cubed is because when I do it again, it's going to be x squared. You just lose a degree each time you do that and come up with a 0, and that will help us find the other 2 zeros. So bring the 1 straight down again, and then -4 times 1, -4, combine, 0. -4 times 0 is 0, combine, and we get -2. -4 times -2, +8, combine, and we get 0. And then we're done. So at that point, so that was x to the 4th. This remainder was x to the 3rd. Now this is x squared. So we want to write this remaining polynomial. This is x squared, and then 0x, and then -2. So from here, we're going to solve this and find the remaining polynomials. Set this equal to 0, add 2. So we have x squared equals +2. And then to solve for x, you got to do the square root of both sides. And then the square root of x squared is x. And that is going to be a plus or minus square root of 2. So those other ones are irrational. I wouldn't have been able to figure those out from the calculator anyway. But we get all of our zeros. So x equals -2. X equals -4, x equals positive square root of 2, and then x equals negative square root of 2. So this is all 4 zeros that we just found, and it wants me to factor completely. So when they say factor completely, you just basically take the zeros and write them as linear factors, which means set it equal to 0 by moving this to the other side. So if I add 2, that will give me x plus 2. If I move this over, that will give me x plus 4. Going to the same side of the equal sign as x and change the signs. If I move this one over, that's going to give me x minus the square root of 2. And then when I move the negative over, it's going to give me x plus square root of 2. So this is what they mean by factor completely. In order to factor completely, you have to find all the zeros. X plus 2, x plus 4, x plus, need the keypad, square root of 2. And it doesn't matter that you put them in order. When you multiply, you can change the order. And then this is x minus square root of 2. All right, so that would be factored completely. All right, so part 2, we want to find the degree. So the degree here is easy. It's already in standard form, so I can just write my degree as 4. And then my y-intercept is just my constant term, because if you plug in a 0 for all the x's, all of these will cancel out, and you'll be left with negative 16. So we get 0, comma, negative 16. The number of x-intercepts where f crosses. So once we did it in the factored form here, all of them have a degree of 1. Okay, so it's going to cross at every odd power, so it's going to cross at all of them. And again, you can see that from when we graphed it. 1, 2, 3, it crosses 4 times. So crosses 4 times. And here are the numbers where it crosses, but we're going to write them as ordered pairs. So that's going to be negative 2, comma 0, negative 4, comma 0, and then negative square root of 2, comma 0, and then positive square root of 2, comma 0. So these will be your x-intercepts where it crosses. And then the last step says the number of zeros where it flattens out. So it only flattens out when the power on those zeros is greater than 1. And none of these have a power greater than 1, so there are none where it flattens out.